Hi everyone, welcome back to Becoming a ROS Developer here at The Construct, our YouTube channel. Today we have Tiziano. He's a student of ours who's going to show us his project for ROS Navigation in 5 days, in which he creates a program where he can do autonomous navigation, and he can do it both in a simulation environment and in a real robot environment. So we're excited to see what he has to show to us. So, hi Tiziano, how are you doing?
Hey Rigo, I'm glad to be here. Really glad.
Oh, I'm glad to have you here. So, whenever you're ready, you can start sharing your screen and show us what you've done with your project.
Okay, sure. So let me go ahead and share my screen and give me a go ahead if you can see it.
Yes, we can see it.
Okay, so yeah, I like having this big screen. So yeah, I mean, working with the real robot, it was really fun. Like the first time I opened it, it was like, oh, wow, I can't believe it. I can connect with a drone, with a robot, like on the other side of the city. It's beautiful.
I'm glad to hear
So
that.
I just got started. I got a head start, and I created the map of the environment. And of course, I have this stupid zoom. I created this map of environment because today is a little bit different from last time. So I launched my G mapping node. I created this map. Pretty simple. Let me show you. It's just 3 lines of code. It's just a launch file. So let me see if I can see it. The mapping. I have the launch file. I have the G mapping, and can I zoom in? I can't. But anyway, it's just launching the G mapping node, setting the proper frame, the base frame, the autumn frame, and a scan topic, and then I drop it around, and the G mapping node build this map. It's a little bit skewed, but all in all, it did a job.
Right. And what are the problems that you see with this particular map? So there's one that we're always struggling with, and I wonder if it happened to you, the symmetry of the map.
Yeah. So this is not particularly symmetrical, and it looks like the robot is slipping on a little bit on sideways. So probably the geometry is a little bit skewed.
I'm sorry, you said it was doing what sideways?
No, I mean it looked to me that it was like moving a little bit. It was turning a little bit, so it was one of this wheel was a little bit slipping. That was probably just an impression this morning.
I see.
But yeah, I mean, I got the map very quickly. I could also rerun it to get it a little bit better, but it kind of like did the trick. So I think it's okay for now.
Yes.
Yeah. Then I save it with a map server, and then I put it in my local folder. So here I have a maps folder in my Turtlebot mapping. I have a map folder where I collect this map. See, I have the YAML and the PGM, and the YAML, I just put the location of the PGM, and that's really it. And then you call the map server, and the map server just provides the map to the nodes that they need after this exercise. And so that's exactly what I've done. So here in the map server, what I've done right here is I launched map server itself with the map that I just created, and in RViz, here you go, you got the map.
Right, nice.
So yeah, that's really nice. I also went ahead and launched the AMCL. Now, AMCL sometimes is really struggles to find the location.
That's what I was. That's sort of what I meant with
AMCL. Yeah, AMCL is like, where am I? This map is probably too.
It's too small and too square.
Yeah, too unique. Yeah, exactly. not enough unique. Yeah, so sometimes like it goes out of the walls, and I was like, no, you got to go here. So yeah, I took like a couple of rounds to just browse around and sort of let him understand where he is. But now, like, it looks like if the joystick appears, the joystick
I think
it's gone.
I think it's not going to. So you need to connect and disconnect. So if you want
from here,
Probably
No,
better
from
to
here.
no, I wouldn't do this because it'll just
No,
take too long. I
yeah,
would just do it teleop,
yeah,
you
that's
know?
the teleop. Yeah, that's the teleop. I like the joystick though. Okay,
Yes,
so
but
ROS run, no, don't worry. Does run teleop to his keyboard. Boom. And let's slow it down because he doesn't like it going fast. So let me Z.
yeah, this is for like a simulation.
Yeah. And let's see if I can go here. Okay, so let's see what it happens. Hey, too fast.
So
Yeah, it stopped. Yeah, it went too fast. I need to stop it. Yeah, because the real robot has a self protection. If he finds it goes too fast, then it just stops the connection with teleop. Okay, yeah, no, again, I had to go even slower.
yes, we have a
What is 0.
safety speed limit, but looking at this, we might raise it.
Yeah, I have a 0.08. Let me try again. I mean, this is still fast, but it's doing okay. See, it's a little bit, the localization is not very good.
So
Look,
where are we looking at the localization? What is the what can you
see
explain
here.
what we're looking at in Arvis?
So in Arvis, I'm looking at the covariance.
Of the
So
pose estimate.
yeah, so I'm looking. I'm plotting the. Let me see if I can show it a little bit bigger. So here I'm plotting the robot estimated localization, and then here you have the covariance, and you can see that it's very wide.
Yes.
And it shows even better if you show the pose array. So it's if you show like the actual particles or the particle filters, and you see that they're very spread around. Especially it looks like has an uncertainty on the direction, and so all those particles are propagating in different direction.
Mm-hmm.
So at this point, I would try to eventually try to reinitialize the position. Sometimes it doesn't help.
Yeah, you know what I actually do a lot of the times?
Yeah.
Well, there's two ways. So one way is to just move it around, call the global localization service that AMCL provides, and just move it around. Or launch navigation itself and send a goal, and while it's traveling,
and let it go.
and it's going to. I mean, it's not going to crash because it's still
No,
going to use the laser
the
scan
local. Yeah.
to.
So let's do it this way. Let's actually do this. I mean, it's not, at least it's not terrible.
Yes.
Let me remove the particles, and let me remove the curve. You want to leave it the covariance on?
I mean, it looks nice.
It looks nice. It really looks nice. Yeah. So now that we have an approximate position and we have the map, what we want to try to do is the next part. And one of the things that I created that was part of the exercises is the, let me see, in the mapping, it was, let me see it. No, it was in the localization. Yeah, it was in the localization. So one part of the exercise was try to go in one place and then save a location. So moving like to like, for example, now where I'm at, and say, okay, I want to save this location here so I can retrieve it later.
Mm-hmm.
So one of the exercise was to do exactly that, and I created this file. It's very simple. Can you read it properly?
Yeah, can you make it does Control Plus work?
Control Plus, Control.
Yeah, there you go. I mean, just to show us the because we can see perfect.
Okay. Perfect. Okay. So this is pretty simple. I use a file that's called position table that you can see right here. And I created this new service, my Turtlebot localization, that you can see right here. It's the called save the spot. Just you request through a label, and then you answer, yeah, it's fine, and then it gives you a message through a string. And then in the file, basically the main callback function is this right current pose, what happens is that there is something that's subscribed to the post that is posted by the is published by the AMCL.
Mm-hmm.
You subscribe to the post, you save this post, and then here this write the post. What it does is it checks the covariance. So it says it understands whether the covariance is like within some limit. I put 0.5 here on pretty generous.
And that's to make sure that
Make sure that
it's properly localized.
Yeah, I list the code. It means that it's basically just the covariance tells you like how it gives you like a metrics for how good the localization estimate is.
Right.
And so if it's within a certain margin, you say, okay, it's pretty much reasonable. So I'm gonna keep this path. And so the way that this algorithm works is that you provide a label, like, so I don't know, corner.
Mm-hmm.
And then he says, okay, I'm taking the covariance is fine. I'm subscribing to the post is fine. And so it's writing a line in this file, and in the line is written the position. So the label that I'm asking, and the pose. So X, Y, the two coordinates, and then the whole quaternion, just because why not? And that is really it. So if it works, great. Otherwise, it responds like, no, position not saved, the covariance is too high.
Right. Because it's, that's a nice check right there.
And then you can see that there are like those two. So there's a subscriber. It subscribes to the pose with covariance stamped to this AMCL pose topic, and then I publish. I create this service that I call TIFF, Save My Pose. TIFF is my acronym basically.
Oh, okay.
I can find them quickly when I do service list.
Yeah, that's nice.
And,
yeah.
And that's it. So basically, I actually can show. It's probably easier if I can show you right here what happens. Let me go. Okay, so what happens is if I go and say, okay, so this is the position. I say that there's a pedestrian. So let's launch this spot recorder. I created a launch file. That's launch spot recorder. That launched just the node. So I could even launch the node like a ROS run. My localization and then spot recorder. It's the same thing. It's one node that can just launch the node itself. So now that I have the node that is launched, it's updating pose. So it is waiting for is getting the pose from the AMCL.
So you're waiting for the service that you're going to call to record that pose.
Yeah. So let me go in another screen and say, first of all, let me move it a little bit. What is it? Let me move it a little bit. Okay, let's move it to the other. Okay, let's say like here. I don't know, here. Then I'm gonna say, okay, so ROS service list. And you can see that there should be, there you go, there is TIFF, save my pose. So now this is waiting for me to send him to call it. So I can just say ROS service TIFF tab should autocomplete.
You forgot the call.
Yeah, I forgot the call. Call TIFF. Yep. And then double tab is going to autocomplete the label. Let's call it, I don't know, pedestrian 1. Let's see. Yep, it's saving the pose and it's saving it. Say, yep, the covariance was fine. And
in that service server, you're making sure that the covariance is fine, so you kind of know that it's going. It's around there. Nice. Okay. Yep,
it's making sure. In fact, here to say, yeah, saving. This is the node spot recorder. So that is also, you have some nice log info over here. So we can move it around and bring it, I don't know, to this corner. Let's not like take too much time.
Right. Yeah.
Okay, and let's save it again. So we do a corner. I don't know, because I have a lot of corners. Like let's call it corner 5.
Okay.
Whatever it is. There you go.
Nice.
So now if I open the code editor and I open the position table, I would see, there it goes.
Oh, you're yeah.
Yeah,
The
I
spots that
I
you
have
saved.
other, yeah, from the simulation, so that they don't count.
This is good though. That way
And
we
there
can
it
try.
goes.
All
Yeah,
right. So, and this is without the path planner. So now
this is without the path planner. Now I
we
save now I saved the spot, and now we can say, okay, let's try to launch to make this vehicle reach those location.
mhm.
So at this point, we can launch the let me see, we can launch move base.
Move base. Yeah.
Okay, so from move base, I have this package. It's called my Turtlebot path planning. There basically is, let me actually zoom in again, because I want to explain a little bit. So in the Turtlebot path planning, there is only one big file. That's the launch file. See that I always have, I create a file, a launch all until now. So every time in my exercise, when I progress through the project, I always have a launch file. I just launch this one, and it would launch everything that I needed until that point.
Right.
That was coming very in handy. So the move base, I have the global planner is going to be nav and ROS, and the local planner is DWA. So nothing fancy. I tested also trajectory planner, worked fine. The TEB local planner, I haven't tested a lot. Had some struggle, but I definitely want to go back to it.
Mm-hmm.
So here there is like I launched the global local planner, and you launch the move base, checking this move base params, and then all this YAML file. So there are different YAML file that I created in this params folder. And the main one is the move base params, and here there are like a bunch of settings. One is pretty important, is this controller patience. I found that it has to be, especially in the real robot, in the project, you need to be patient. Otherwise, it just start complaining about the time synchronization, and it doesn't work. I set in the DWA planner, I have the velocity, so it allows the vehicle to go forward and backward, so it can get
Okay.
unstuck. There is still a minimum velocity forward. I found that setting this one to 0 doesn't work at all. You have to keep it a little bit positive. I'm pretty generous with the goal tolerance.
Yeah.
And also the sim time is like, 1.5 to 2 seconds. I saw that it worked pretty nicely. And of course, I have no particles on the, or no, whatever. On the y direction, I only have in the x direction and the theta. So I give a wide range of opportunity in the theta, and also a pretty close range on the x. So we keep the control frequency at 10. Everything else is pretty standard.
Yeah.
I
Like
check on the,
standard defaults.
yeah. So
I'm sorry to interrupt, Tiziano, but I'm looking at the time, and I'm assuming you only
okay,
have 9 minutes left. So
let's try this.
could we, yes, launch it and see,
Yeah,
and then we can go, and that way it doesn't matter if we run out of
yeah.
time.
ROS launch my Turtlebot path planning, and then move base. Boom.
So at this point, we should see
At this point, we should see,
some cost maps or something, right?
yep, especially if I turn them on. Okay, so let me enable the global cost map. There it goes. So
Right
this is a
on.
really good sign.
Yeah.
And a local cost map, it will come right after. Let me actually disable the global, so that we can see the moment that it comes in. So it's requesting the map, still there. Laser scanner. Yeah, it's you see the laser scan is completely skewed.
Yeah, but so
Yeah, we'll try.
yeah, at this point, are you able to send a navigation goal?
You see? I think it's still requesting the map.
That's strange.
Yeah, even before it took a little while to start when I tested. Yeah, it took a little while to start. Oh gosh, what happened?
Oop. I think it's your first tab.
Okay. I don't know. Because the map server stopped.
Oh,
That
so
is
when you
probably,
when you're launching.
yeah. Now that could probably explain why I couldn't find a map.
Right. So you didn't put in your Pathfinder launch, you didn't add your map server, so you do it separately, which is actually a
No,
good.
yeah, I keep it separate because I had another launch file where I launch everything. And usually I don't keep in the same launch file because when I debug,
Exactly.
I close the node, I don't close everything else. Yeah, okay, now it's working. There it goes. You see the global. Oh, okay, perfect. Yeah, the map server was absent.
So we got like 10 more minutes, Tiziano.
Okay, let's try. Let's see if it works. I think now it's too stuck. He thinks it's too stuck on a corner to try. So usually what we can do is we can give it a hint. Oh, there it goes. It got a new plan, got a new plan. It's actually speeding pretty fast.
I like how
Look
it
at that.
backed up.
Look at that.
That's
Oh, this
nice.
is so fun when you see it moving this fast. It's just
Yeah,
nice.
yeah. And I
Look
like
at
how
that.
it did
There you guys.
that backwards movement to get
Yeah,
unstuck.
yeah. And that was really neat. That was really neat. And well, look at that. I mean, even if the global map and the AMCL they are very off because this is
Yeah.
especially the heading is off. The local planner is really doing a good job in bringing him there and
Yeah, yeah,
avoiding
yeah.
the obstacle. So kudos to it.
And
Now,
that's why it's good to separate it, because then you get like, how can I could localize it better and then debug that because there's 1,000 parameters, and then the part on the
yep.
planner, it's a nice.
Now, for the last thing is let's launch the last thing. That's the server. So it is the what is it? What is it? The navigation. So in the last exercise, I have the navigation where I simply let's just launch it. So I'm going to create this. I'm going to launch this send go, and this will allow to ROS launch my Turtlebot navigation, and then send go. Now this creates two services. One translates the label that I'm sending to a pose, and the other one subscribes to the pose and actually connects to the action server move base, and it sends the final goal.
Oh, nice. So here you'll be like,
yeah. So in fact, if I have a ROS service,
go to something.
Yeah, list. I have. There it goes. The sec goal from label and get my post service. So I'm gonna do ROS service call if set go double tab, and what was it, like corner 5?
Yeah, that would be a good place to try.
Now, if he doesn't find it, it will say nope. I didn't find it. Otherwise, yeah, there it goes.
Right on. So this way you can label the entire map. Say,
yep.
I don't know. This you can translate it to go to charging position.
Yep.
Go to
exactly.
Pick up something. Go to
And then in the end, there's always this little dance because
it's trying to that tolerance, no?
Yeah, I had to adjust the tolerance.
Yeah.
And it's anyway, here you see the result is true. So it says, yep, I'm done. And then I can go, I don't know, what was it? Pedestrian 1?
Yeah, I think it's PED1.
PED1.
Yeah.
Yep. Let's see if it should go backward at this point.
Oh, nice.
Yes, there it goes.
Nice.
Yeah, now it's
I was trying to find that
this
point exactly.
Oh yeah, this is so nice.
That's great.
Yeah, let me remove the global map, the local map. Yeah, this is This is really neat. I really love it. Um, Especially in the real robot, it looks so nice.
Well, yeah, it's the final step, and that's sort of what we're trying to provide for
Mm.
to learn, because there were things that were gonna come up, like that patience that you talked about. I didn't
Mm.
that I hadn't actually known, and just that extra step, and it's just nice to see it actually work.
Yeah, this is really good.
Tiziano, before the call ends, do you mind stopping sharing your screen so we can
Sure.
just sort of do an outro here? So that was amazing, Tiziano. That was great and very structured and very easy to understand. And I like how you separated everything nicely into localization, path planning, and then using the spots that you created in your position saver, and then sending it to the to the move base. So in that scenario, like, congratulations, like that's a perfect project. I really liked how you did the covariance to check to make sure it's, well, this position is no good if the covariance is too large.
Mhm.
So I really thought that was really good. And let me just ask you to finish up. What were the most challenging, like the part where you had to tune the parameters too much, or
Um,
the other Python program that you struggled with?
no.
What is the
Okay, so
bottleneck here?
yeah, no. So my personal bottleneck is, I mean, besides I always struggle with service and action uh, if I don't use them for a while. I
Right,
always
to set
forget,
up
and
the
I have to.
server and
Okay, what is the how can I make a service and the actions, and it's always like going back, because usually you use topic. It is the one that you use the most,
mm-hmm.
but that's besides the path planning for sure. The local um, so the move based parameters, tuning the parameters, and also finding the right values, and also find the right inflation for the cost map and the local
Right.
cost map. That really took me a while. So not only I did the exercise, as it was an old exercise, but I took like extra days to really try to dig in and study and understand and find other examples online and people, so that I could really understand why something couldn't happen. It couldn't
Right.
work. In the beginning, it wouldn't work at all. It would just really get stuck somewhere and not coming back, coming out. I always have to go with teleop twist to just move it.
Right.
In the end, I found that you have always to give it a minimum speed to make it work,
Mm-hmm.
and that really helped a lot. So yeah, that was the part that I had to study the most and pay more
Right.
attention. Everything else, it was like, okay, it's
Right, because at the end of the day, that's what makes the
yeah,
move base good. You know, precise is
exactly.
to look at what your robot looks like, and what their capabilities of it are, and then tuning those parameters. But I mean, the first big hurdle, at least for me, is to in a new robot, is to get it to work. So once you see those
Mm.
cost maps appear for the move base, you're like, all right, that looks good. Let me try and find it.
Yeah,
And
yeah.
if it doesn't find it, that's another story. But at least you have a base that you can
You have a
start
base.
tuning on top of that.
Yeah,
So
no, that was really fun. I wanted to dedicate more time on with that, but in the end, I think it worked pretty nicely. And
it looks like it did its job, and that's what we asked for. And hey, listen, Tiziano, congratulations again. That was a really good project. I'm gonna cut us off here before the
okay,
call stops suddenly, and it's kind of not nice, but congratulations. This was a perfect project, and to whoever else that's watching, this is what you can do if you take our courses, and then at the end you prove your knowledge with a real system, and then you know how to set up a navigation autonomous system, and then adapt it to whatever robot you might want to use. So check it out if you guys want to learn about autonomous navigation. And Tiziano, again, thank you so much for your for showing your work here, and congratulations again.
thank you very much, guys.
All right, you guys. So see you next time for our next presentation. So we'll see you soon. All right. Bye-bye. Okay, Tiziano, it's done. Sorry about